In this video, we're going to look at how phase difference relates magnetic flux linkage and the coil itself. Sorry, the EMF through the coil itself. Now, the equation that links this actually combines two laws, Lenz's law and Faraday's law. So I'm just going to very quickly write out the equation and then I'll explain what both laws are before explaining the phase difference. Okay, so the fact that EMF is directly proportional to the rate of change of magnetic flux linkage, that's what Faraday's law is. Now, what is flux linkage? Flux linkage is the multiplication of the number of turns of coils in a wire multiplied by the change in magnetic flux. You can break magnetic flux down further by saying that it's the magnetic flux density multiplied by the area. If it's ever a case where components are not perpendicular, then you have to take the component that is perpendicular. So you might need to express it as BA cos theta. That's going into quite a lot of depth and that's related to something else. But Lenz's law explains the negative in this question. It shows that the EMF that's induced acts in the opposite direction to the voltage that initially created it. Now that we know this equation, it sort of tells us that whenever magnetic flux linkage is as positively large as it possibly can be, EMF will be as negatively large as it possibly can be. So they're always acting sort of in opposite. With phase difference, I always like to tell my students to think of a wave. The reason why is because if we're looking at where magnetic flux linkage is largest and where EMF is smallest, the difference between them correlates to a half of a wavelength. If you think of a full wavelength representing 2 pi radians of phase difference, then half of a wavelength would be exactly half of that. So it would correlate to pi radians of phase difference. And that's why D is the correct answer in this question. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.